Welcome everybody to our webinar, Machinations 102. Today it's the deep dive into registers. Those of you that have joined any of our kind of previous webinars, especially our Machinations 101 session, you'll remember that we only kind of briefly touched on the power of registers, one of the most versatile objects inside the platform. So today we're going to give you a solid understanding of registers and how to use them inside your models. We're going to learn how to use interactive registers, and really we're going to focus on all the Maths.JS functions and see how they can be used to create your game logic. And we're going to use them to create arrays and integrate them into your models. Before we get started, if just down at the bottom of your screen you'll see the little chat button somewhere. If you could hit that chat button, and then as default it's going to say to all panelists. If you could change that to all panelists and attendees, then what I'm going to ask you to do is just drop into the chat where you are in the world and which studio you're from, just so we've got an idea of who we've got with us today during the session. While you're doing that, allow me to introduce myself. I'm Matthew, I'm the evangelist for Machinations. Still horribly addicted to Factorio, and I've pulled Mihai into playing Factorio with me as well now. Alongside me and talking through most of the content today is Cesar, our diagram craftsman. Lurking about in the chat will be Mihai and Horia. As usual, they'll be keeping things flowing in the chat, answering any questions that come up if we don't get a chance to answer them live. At the end of today's session, something we've started to do after each one of our webinars, we're actually going to just kind of open up the floor. So if anybody then wants to come and join us in the chat, actually you can turn on your microphone and ask us any questions as well. Could be about what we've been through in our content today, or just anything around game design. Throughout today's sessions, please do drop your questions either into the chat or into the Q&A, and we'll answer them as we go. And we're going to have we're not going to have too many polls in today's session, but I'm going to kick off with a quick poll just to understand how much you've used Machinations so far. I'm going to use this to seamlessly transition over to Cesar to share his screen. Good morning, Cesar. So in that poll, how much have you used Machinations so far? Not used it at all yet, a few doodles, subsystems, full meta, or everything in there. Give it a couple more seconds to pop your answer in, and I'll close the poll in 3, 2, 1. And in the poll, and I'll share the results. Fantastic. So we've got the perfect mix. A couple of people not used it yet. A lot of people just doing some doodles. So this is the perfect session for you. And a couple of people going all the way up to full meta. So hopefully there'll be something new that you didn't know you could use registers for today. So Cesar, looks like you've got lots of different models for us today. Do you want to talk us through how you're going to go through this and talk to us about registers?
Yes. So those of you that have been at the 101 know that we've split our different nodes into different sections there. Registers will be no exception today, except that a single node is going to take all of these sections that you see here. The way I've split them now is based on the type of formulas that they use, because registers support Maths.JS functions, a lot of them, not all of them, but a lot of them. I've tried to include as many of them as possible, at least the ones that I personally know and can talk about. And I've grouped them in each in their own category. I'm gonna try to have at least one example, one model for each category, so you can see how those formulas help you with your systems or subsystems. And please, if you have any questions at any time, please ask them before I move on, because if I move on and those questions remain unanswered, it might get fuzzier as we go on. So as soon as something is unclear, please just stop me and let me know. Matthew will hopefully buzz right in and stop me. So with that being said, we're gonna take them in order. And our first category here, arithmetic functions, is actually our largest. You'll see this type of model throughout the whole webinar. Let me zoom in a bit more, where I have two input pools, and I send them as the variables A and B inside of the register, where I use all of the different formulas. So this is going to be used throughout the webinar today, with some exceptions, but we'll talk about them when we get there. I'm also just going to do one single step because the register won't need further steps. It will apply the formula during the first step. So we're going to start with some basic arithmetic functions, which are add, subtract, multiply, and divide. Those are pretty self-explanatory. I'm not going to insist on them. The final one is power, A and B, which raises A, in our case 4, to the power of B, which is 5. This one is a bit more useful, and the most important thing to note about this particular formula, the one with power, is that it doesn't really have a replacement. So most of these, you're going to see throughout today that most formulas can be approached most subsystems can be approached with different formulas that give the same result in a sense. You'll see what I'm talking about, but power is kind of irreplaceable, and power is very useful for leveling up mechanics experience curves because those are exponential in general, and generally any formula that has an exponential growth will use power. So those are the first 5. Moving on, we have approximation functions here, starting with absolute, which is the absolute value of a number. You see that it can support a single parameter, but we can do an operation inside. So I could have had absolute A or absolute B minus A. We can perform an operation inside of the formula. I could have made the formula absolute subtract BA, so we can include a formula in another formula. That's also allowed. It returns the absolute value of a number, so we have minus 12 in here. We ditch the minus, it's a 12. Ceiling is the first type of approximation. It approximates your number to the highest available, closest higher integer. So in our case, 17 divided by 5 is 3 something. Ceiling is going to round it up to 4. Floor is the opposite of ceiling. It rounds it down, so it's going to round it down to 3. Fix rounds it towards 0. So if it's positive, it's rounded down. If it's negative, it's rounded up. And rounds it to the closest integer. So if 17 would have been an 18 in here, and I hit another step, round should turn into 4. There we go. And mod is the modulus of the division between A and B. This is useful for cycling mechanics in general. If you want to cycle between 5 different stages or something, having a modulus, so increasing A every step and dividing it by 5 and checking the modulus is one way to do it, for instance, because it would cycle between 1 and 5, 1 and 4 rather, and you can implement those cycling mechanics. Next up, this is what I was talking about. So we have some exponential functions in here, which are specific ones: square, cube, square root. Sine is a bit different, but I just included it here. I didn't want to make a whole category for it. Sine just computes the sign of the parameter here. So I have sine of minus A being positive, minus A negative, so the sign is minus 1. And if A is 0, sine computes 0. But for instance, square and cube, you could remember those because they are useful for square, but you can also just do it with power A and 2. So there's no need to remember many formulas because some of them can be implemented in other ways as well. We have some logarithmic functions in here. Now, I've never personally used logarithmic functions. I guess some of you who are more familiar with them would probably find a use for them in game mechanics. I didn't, but I wanted to showcase that they do exist. You can do logarithm between 2 variables. You even have some specific logarithms, and they all work as expected. And finally, to top of arithmetic functions, we have lowest common multiple and greatest common divisor. I've selected 15 and 5 as the numbers so we can see them easier. Obviously, the lowest common multiple is going to be 15, and the greatest common divisor is going to be 5 in here. You can take note that those 2 functions can be used with more than 2 parameters, so you can have as many parameters as you want in there. And with that being said, I want to move on to the example that we have here, which is the one I was talking about when talking about power. In here, we have let me reset first, a basic experience curve. So we generate experience every step. That's going to be your system on the left with the battle system or whatever it is that generates experience, your matches. They are going to go into an experience pool where you store it. And you're going to be using a converter to convert that experience into levels whenever you reach the required amount. And that amount is going to be calculated with this formula. Now, this is a generic formula that I created, obviously. We have power 1.15 to raise to 8. So in most, I'm just going to hit play while I explain. In most games that I've seen with experience formulas, this is sort of a generic exponential formula. So the level raises steadily at the beginning and then really the curve really gets steep once you get to the higher levels. You can see here the cost that it takes to level up. And the reason that I use floor before the whole formula, the reason that I want to approximate it using floor here is that using exponential formulas can give you a number that is not an integer. And having a number that is not an integer causes the converter to not understand what it's supposed to convert, since you can only transfer integers using resource connections. If you transfer a non-integer number, then the converter is not going to output anything. So the simplest way is just to take that number that you get and round it down by 1, and then the converter will work perfectly. So this is also an example of using formulas in combination. You can combine 10 formulas in a single register if you want to. It's fine, it's going to work. Just be careful of opening and closing the parentheses, because most of the time I get it wrong the first try. So yeah, be mindful of that. So this is the basic example for experience, and one of the best uses for arithmetic functions that I know. And I personally use it in all leveling type games that I do. This is pretty generic stuff. It's always there.
That's a great tip to make sure you're always using integers on converters.
Yes, for converters, be careful to always use integers. If you're getting non-integer numbers, just approximate. Use whatever function. I use floor, but you can use whichever one of these. It's going to be fine, so it doesn't really matter.
Perfect.
The next section is for those of you that have a programming background. I don't feel confident enough to explain what bitwise functions are. I feel confident enough to show them and to tell you that I've used 17 and 5. Oh no, I used 2 in here, but I used 5 at the top. I've converted 17 and 5 into binary numbers. And those of you that do know them will understand that you can do an AND operation on bits, so selecting bit by bit to see if they match, and an OR operation on bits and XOR, and you can also do some shifting. The reason I don't want to insist on these is because I've never found a use for them. I really don't know what they can be used for, especially in a game mechanic. Maybe those of you that are more experts than I am will find a use for them, but I don't know. And I really didn't want to insist, but I do want you to know that they exist, those functions exist, and they do work properly. So you can make use of them if you are a master of bit operations. I don't have an example here because I really have. If you guys have if anyone in the audience has any idea, please let me know. I would be very interested to know what you can achieve in a game with bitwise functions.
One of the things we're always surprised at is seeing what people kind of create with Machinations.
Yeah.
It's quite often we're completely blown away with the creativity and what people are using Machinations for. So I'd love to see if anybody comes up with a use for those types of functions.
Exactly. Moving on, we have logical functions. I remember not too long ago, someone asked me if Booleans can be implemented. Now, the answer is yes and no, because Booleans are sort of implemented in the sense that 0 is always 0 and anything but 0 is 1. So 7 translates to 1, 15 translates to 1, even -3 translates to 1. So any number but 0 is a 1. This is the way that logical functions are implemented, since they only technically work with Boolean values. We have some basic logical operations in here, those 4. I'm just going to hit a step. You can see and checks if both of them are different from 0, or checks if at least one of them is different from 0, and XOR checks if one of them is 0 and the other one is not. Not is the opposite of the value of the function. If I hit resume here and I drain so that a becomes 0, you can see a becomes 0 and XOR becomes 1 and not becomes 1. Those are pretty self-explanatory. They are useful in mechanics where you need to fulfill multiple conditions in order to obtain something. They can be achieved with other formulas as well, but we'll get there and I'll explain that later. So in the mechanic that I thought about here, but I'm going to increase these chances live because I don't want to sit here 10 minutes waiting.
There is something about a webinar and any kind of randomized value means it will never happen while we're streaming.
And I don't want to risk it. The thing is, the mechanic that I implemented here is a level where you need, let's say, for all of you Doom fans there, you need to find keys to open doors, and until you open those doors, you cannot complete the level. In our case, you need 2 separate keys for a single door, but you need to have both of them. And I check, you can see that I play right now, and A and B is obviously 0 because we have no values in here. We found the blue key, that's not enough. We still need the yellow key, and once we find it, we get a value of 1, open door becomes active, and we can complete our level. So it's great for mechanics like this, where you need multiple conditions to be fulfilled in order to obtain something. Of course, OR and the others can be used in the same way.
And that's a really good, the way you've got that set up, having the condition come out of the register to be greater than 0. So whenever there's a condition inside that register, if that condition is fulfilled, it's going to return the number 1. Is that correct, Cesar?
Sort of. For logical functions, yes. For arithmetic functions, not really, because if you add, if you square, if you power, not really. But where you have, yes, logical functions, they only return either 0 or 1, either true or false, basically. So, yeah.
Perfect. So then using that greater than 0 is a great way of kind of saying that if that logical function is fulfilled, it's going to return a 1. 1's higher than 0, therefore it's going to use that condition on the state connection to activate the next object.
Exactly. Next up, we have matrix functions, which is actually something that I discovered quite recently, and it was kind of a game changer. I know that when I showed Matthew this, it was a game changer for him as well. So we talk about matrix functions, but we only have 2 functions here that actually work, because we can't actually implement matrices. We only implement arrays in here. And the way to implement an array, I'm gonna do a close-up here so you can clearly see on the register here. This is the way to implement an array of your choice. So if you want to control the elements that the array has, between square brackets, you enter your number separated by a comma. So if I hit play, you're going to see the array small in here. If I click on it, you can see in the top right, you can see the elements. And this is the way that I use to cycle through them. Maybe there is a more efficient way. I don't know. I'm just used to doing it this way. So I just generate each element turn by turn and access them one by one and reset when I get to the capacity. Of course, arrays can be implemented by using external values, so you can have values come from pools or registers or whatever else, and send them as variables inside, put those variables between square brackets, and it's going to give you the same array. So it's the same result. Again, you can cycle it with the same mechanic, you can cycle through it. And now to talk about the 2 functions that you can use with those arrays. First one is size, which returns the length of the array, in our case 4. And the second one is sort, This is actually a very useful one. It returns the array in ascending order. So you can see that with the sorted one, when I go through it, it's going to be in the correct order. This is I personally find this very useful when you have a lot of elements coming in, maybe think 20 elements coming in, and you want to get them in order. You want the smallest one to receive a prize first or something. Maybe it's a ranking, maybe it's, I don't know, the smallest experience character in your party or something like that. And it's really hard to sort those elements, but placing them all in an array and just hitting sort in a register solves that for you instantly. So it's a really useful mechanic for this type of things. And I'm gonna reset and zoom out a bit. Yeah, I want to show a use of an array. So for instance, those of you that have seen the Hades webinar, if anyone is here that's seen that, when we chose the rooms that Zagreus can enter, we could have used an array as well. I didn't do it at the time because I didn't feel confident enough, but that could have been a way to implement those. In our case here, I have a simple model where, let's think daily events in a game, daily live events. So let's think that you have an event with the code 1, let's say event number 1 in the first day. In the second day, you would have event number 2. In the third day, event 1 is recurring. Then you have event 3 and so on. You have a rule like that. And by cycling between days, so the pool here will be the day counter. By cycling between them, you can activate parts of your system for that specific event. So instead of having a simple pool here, think that you have an entire subsystem for that event, and you only activate it when the day is right, so the event is active. I remember that I made a model like this for daily events for a month, and the way I implemented it was I used an array and inserted all 31 days in there by the respective events, and then just use that array to cycle between the events, and each event will become available in that day, in that specific day. So I find it very useful for this type of mechanic. And that's about it with matrix functions. Again, arrays, really useful. Really like them, really useful. Next up, we have probability. Those aren't many. You can see we have only a few of them. If I hit play right now, a factorial is just a mathematic function.
There's a quick question on how is this done in Hades in Machinations. Actually, in a little while, I'm going to take you through an example of a quick model where it's very, very similar to how we implemented it in Hades. So we'll take you through that when we get there.
Yeah. Matthew's got a great model incoming. Watch out. So yeah, hitting play. Factorial is just the function factorial. You might find use for it, maybe just know that it works. But those two functions that follow, random and random int, those are fantastic when you want to simulate player skill in general, and maybe factors that are outside of the game's control. So when a player plays your game, there's a lot of games that, based on how good the player is at the game, will give different results. So a good player playing a racing game will obviously win more races, have a faster progression through the game, and so on. And that's pretty hard to simulate and control. But one way of using that is generating a player skill using a random number, and having that random number be sort of the seed for the player, and act as how efficient the player will be at the game. And obviously, being random, you can just reset, then play again. It's going to give you a different number. Imagine that I have a bigger range in here. It can be between 1 and 100, or however much you want. And then the diagram will look completely different, or on different execution with a different player. But you can test it out and see how bad players progress through the game, how good players progress, if there is too big a difference, and stuff like that. It's also important to note that you don't really have to use variables in here, which holds true for the other formulas as well. So for instance, when you are adding, you don't necessarily have to send A and B. you can just do add and add numbers in here like 5 and 10, and it's going to perform the operation. Same here with random. You don't have to do random int DNA. You can just do, I don't know, 5 and 50, let's say, and it is going to return a value. You don't need those numbers in particular. If you want to control the execution, it's easier to give them the number yourself. If you want an easier way to change the parameters, rather than search for the specific registers and look at the formula, you can have those pools influence the register. It's easier to see them, it's easier to keep track of them and change them.
Just a quick question on there. So when you hit play on that, it's going to generate the random number at the start. It's not going to carry on generating random numbers, right? That's going to stay as it is. How can you do that? Just as a quick example, so that it changes each step or at different times.
Yes. So this is a good question, first of all. But the thing is, this will teach you about understanding how registers work. So registers, in essence, are reactive nodes. So they wait for their inputs to have changes inside before they change themselves. So since our pools are not influenced by anything, the register does not update its information and remains constant throughout the execution. Now, one way to change that is to trick the register into thinking that it's being updated. So in order to do that, the simplest mechanic that I personally call an updater, but it's just 2 nodes, is having a source going into a pool and that pool going into your register. Now, as you see, the state connection became C. So I'm sending the pool as the variable C in here. We're not actually using the variable C, but it doesn't matter because since it is an input for the register will think that it's being updated. So because of that, you're going to see when I hit play that whenever we get a new resource, our register updates because it thinks that it's being updated. So this is a great trick to update your register if you want it for a specific case. Maybe you want to change player skill at the 50th step or something. In that case, at step 50, you would just send a resource in here for maybe every 3 steps, like Matthew just modified. You can see every 3 steps, it's going to update. So it's a great mechanic to keep in mind for registers in general. This can be especially useful with random functions because they tend to generate themselves rather than waiting for outputs. Pick random works as well. Just going to reset here a bit. I'm going to leave it there. Pick random, you can see we have an array in here. Pick random selects one element from that array. So if I hit play, it selected 3, but it's not selecting anymore. So the one that selected is the one from the start. Again, this is a good way to implement a seed generator. If we were to add that updater that's slowly disappearing from the top, you would...
I was tidying up after you, Chizza.
Yeah, of course, thank you. The element that is updated, that is picked, would be updated at every step. That doesn't mean it cannot repeat for consecutive steps. So if you were, let's say, unlucky, we could have gotten 3 25s in a row in here, but the register would have been updated. It's just that we got unlucky. So the 2 models I want to talk about here, which are actually pretty similar, but with a slightly different trick to them. You see, we have a random int register in here. I just gave it 1 and 100 as parameters, and they are supposed to emulate player skill. We have player skill in here. What we have is a 0% chance on hit and a 100% chance on miss. So this is a very, very basic shooting type mechanic. Each step we're going to fire 1 bullet, and it's either going to be a hit or miss. Since miss is 100% and hit is 0%, any point of skill that our player has will add 1% to their chance of hit, and any point of skill that we have again will decrease 1% from their chance of miss. So if I hit play right now, you're going to see, since we have a skill of 69, nice, we're going to hit with a 69% chance, and miss with a 100 minus 69% chance, so a 31% chance. As you can see, the hits go on a lot often than misses, so our player is quite good. If I were to first arrange this back to its position, hit again, we're going to generate a new skill, 91, even better. So now we're hitting constantly, and we are barely going to miss. So this is a great way to implement player skill in general. We can also do that, you can see on the bottom, using an interactive register. So all registers that you see here have an interactive tick over here, tick box. If you tick it, it's going to turn into this register here with arrows on the top and bottom. Interactive registers don't support formulas. They are a bit different. They have an initial value that you can set. In my case, I made it 50. And they have a step, which is the increase. I'm going to show you actually, but I'm going to set it to 10. So now when I have a step of 10 and I click on the arrow, it's going to increase by 10. And my chances change accordingly. Now, it is important to note that these changes only occur during execution. You cannot modify it before the execution, except for changing the initial value. And when you reset, so for instance, let me reset at 70, it's going to send me back to 50, which is my initial value. So this type of register, the interactive one, is good when you want to modify stuff manually, so you want to change player skill or whatever the register would signify in your diagram. If you want to change it during execution, that's the way to do it. I personally, if you do it, good for you, but I personally don't really like changing stuff during execution. I like to set sort of a seed at the beginning of the execution and run with that seed, and then try different seeds rather than changing. This is good, very good for interactive ones. It can be really helpful for interactive ones, and I'm going to show an example later where it can be. But during quick plays, you're going to see that if I were to quick play right now, let's do a quick play of one. Should plot something. Let's plot. Okay. We don't care about the chart, but the thing is, you can change the values in here. So it just becomes a static 50 during those executions. And that's why I personally don't really like using them. But for interactive executions, they are great in changing your parameters on the fly. Okay, so that's it for the interactive ones. And this is it for random. Again, those very useful, very, very useful for player skill. Any player skill based game, you're probably going to have at least one register with random int in there. That's the best approach, at least in my opinion. Moving on, we have my personal favorite set of formulas and the ones that I use the most, which are relational functions. Relational functions usually compare the two numbers. So if I hit play, you're going to notice, let me zoom in a bit more. We have compare between two numbers, which returns 1 if the first number is higher, -1 if the second number is higher, and 0 if they're equal. Equal, which checks for equality, and unequal, which does the opposite. And then we have the 4 formulas that I have definitely used the most in all of my diagrams, which are larger, larger equals, smaller, and smaller equal, which check again if if the first number is higher than the second, larger or equal, smaller, smaller or equal. So if I change the value in here to 4, larger and smaller become 0, while the ones with equal become 1 because the numbers are equal. This is the first example that comes to mind where multiple different functions can perform the same. So for instance, in our example earlier, where we had find blue key, find yellow key, aside from using AND A and B, which also works, we could have used larger A0 times larger B0, for instance. And even if it's a longer formula, this comes down to personal preference, because I've used relational functions from the start and I'm really used to working with them. So I can see the formula immediately. I can think of it immediately. Okay, this is probably going to be how the mechanic is going to look like. So this one comes with practice and forming your own style, so to speak. If you're going to start off using AND in your first model, you're going to probably stick with AND for the rest of your models. But my advice is to have consistency here. So don't switch from AND to relational between models. Just stick with one type of formula and have your own style, because it will make it easier to see those patterns in future models that you make. For me, it's the relational ones. So this could have been an AND as well, but this time I'm checking again for two conditions. We have lives in here for our player. So larger A than 0 is does the player still have at least one life left? And larger equal be 5, which is enemy slain. So has our player slain at least 5 enemies? I have a 30% chance here, which I hope is enough for the player to kill the enemies fast. And I hope that the 5% isn't that unlucky that our player is going to die, even though they just lost 2 lives, which is quite unfortunate, but now we're all sweating. Let's see what happens. But as soon as the player kills the 5th enemy, there we go. The upgrade is done. Now, even if the player were to lose their life, doesn't matter. The upgrade already went through. But normally, we would implement an extra mechanic here that when the upgrade goes through, we turn off both the source and the drain, because we don't care about that anymore. But this is also, let's say, the solution would be simple. Just drag a state connection like this and do it equal to 0. So if we do it like this, the moment the player receives the upgrade, we turn off the drain, and the player is no longer in danger of losing those lives. This is a simple way to tie your systems together, so to cycle them to make sure that they do not go on when they are not needed anymore. So this is it for relational functions. A lot of those type of mechanics where you need multiple conditions to be met before you can achieve something. A lot of those can be implemented using relational functions. Your imagination is the limit here. So with larger and smaller, you can make a 1000 node diagram just using those two formulas. Next, we have statistics. Now here, normally I would have had 5 different pools, each going into those registers, but I was feeling a bit lazy and wanted to show arrays anyway. So I just have an array here with 5 elements. Hopefully you can see them. And statistics are used to find the maximum, minimum, let me hit play, the median value, the mean, sum and product, which can also be done with add and multiply, or just typing a plus b in the register. That works as well. You don't really need to use a formula for that. But for instance, if you have, let's say, 50 elements that you want to add, rather than typing a plus b plus c plus d plus, okay, you can just stick them maybe in an array and do sum of a. It might be more efficient, especially if you want to do multiple operations on them, not just adding them once. So it might be more useful to do it like this. Maximum and minimum are the ones that I find the most useful here, and I'm going to show you one type of mechanic. I also wanted to mention that we can also do a standard deviation, whatever that means. I have no idea what that means, but it works. I mean, it returns the result, so I'm assuming it works. So for those of you that are math enthusiasts, maybe you can find a use for this. Just know that it's there and it's working. And the example that we have here, which is already running for a while, so I'm going to reset it. Don't be scared by the bunch of connections.
Quick couple of questions.
Go ahead.
David's had a lot of problems with stopping subsystems in the way just described. However, if the subsystem is separated by more than one link, it will one time for each additional link before stopping. I don't quite understand that, but I think if you just jump back to that little model where you just added that stop function, I think the key to this is just making sure that as the way Cesar's got that set up is it'll turn off the drain once the upgrade pool is larger than 0. So the second, in this example, the second the player's done the upgrade, it turns that off. We can also turn off the source for enemies slain as well, using that same type of logic.
Yeah, so if you have multiple types of generators or drains in your system, you're going to need to turn them all off individually. I mean, you're going to need to draw a state connection to each of them. Now, this comes into play the.
Actually, I think I see the question here, which is if there is an extra node. So in this example, when the register function is satisfied,
okay,
there's then one more step between it pushing that resource into the upgrade. So there's one step that would run before it's stopping that.
Fair enough.
So actually, the way in which you could do that is actually rather than there we go. So rather than taking that from the pool, we could take that from the register itself and use the register to turn off that drain.
It's actually better if you do it this way, the way you described. You're right. My method takes one extra step, and the player can die in that extra step. So it's better to just use the register itself because that is the one that turns instantly, modifies instantly.
It can take some kind of practice and experience of machinations to get that right, because you're right. It's just that one extra step that you could have one where there's actually multiple steps that go on, and you want something to happen, and getting your timing right and using the right logic for those sorts of things can be practice. Please hit the help button if you get stuck on something. Would more than happily take a look at it for you and help you off.
But as you see, so I didn't do this intentional. I missed it as well. So it happens to anyone. Don't worry. You would have made your model this way, then you would hit play. Your player would die at some point, even though the condition was fulfilled, and you don't understand why, and then you'll figure it out and you'll fix it. So it's fine. It's just don't expect to have a good model from the start. After you play, so when I play after I build the model and I hit play, I expect it to be really bad for the first couple of times before I figure out the mistakes I've made. So it's fine. Don't stress too much when making your first model, because the fixing comes after.
Perfect. Just another quick question on the stats functions. Stat functions can take arrays and multiple inputs. Absolutely. So in this example, Cesar's used an array there, all fed in with the letter A. That could be A, B, C, D, E.
That
whatever.
could be the mechanic that is here, for instance. So where we have 3 of them and just have max of A, B, and C. So it works like that as well. Yeah.
Perfect.
Okay. Yeah, I was at the example here. So what we're simulating here is a turn-based party type of game that has agility implemented for its characters. So our character that generates 500, waiting time per step is our fastest one. That character's turn will come fastest. Then we have 700 and 900. If I hit play, you're going to see that we check the minimum each step. We reduce the time. So the character that is at 0 every 2 steps is the character that takes its turn. And we're doing that by using minimum in here and draining the remaining time from all characters every 2 steps. So you can see this is a great way to implement party-based agility type mechanics by using minimum. This is why minimum and maximum are useful in situations like this. And even when we have a tie, as you saw right there, one way to handle that would be, instead of 500, to push 501 resources, 702 here, and 903. So we have sort of a preference for our characters, so to speak. So if in the event of a tie, our second character would go first and our first character would go second, and so on. That's a simple way to deal with that problem. We have 2 more, so we're almost there. This one's going to be short. Trigonometric functions. You know what trigonometric functions are. I know what they are. I don't know what they're useful for, though. I just know that they are. So you can see that they work. I only put 8 in here. There's like 30 of them, I think. There's a lot of trigonometric functions. I just put the basic ones in here. They're mostly the same. Kind of reminded me of high school, and not in a pleasant way. So I just wanted to know that these work. I don't know what they can be used for. Again, the same as with Bitwise. If any of you have any ideas, do let us know. I would be curious to know what you can use this for. I've never used them. I don't have an example for them, but they do work. They are here and they do work. So yeah. And our last one is utils functions. Utils functions usually check for different states of the numbers. You can see that we have, let me zoom out for a bit. Okay. Different checks in here. So is integer, you can have a single variable, but I divided 2, so it's not an integer because 7 divided by 4 is not. Is positive, is negative, is prime, and is 0. This can be achieved with other types of functions. So for instance, is positive is also larger a than 0, is negative is smaller a than 0, is 0 is just equal a to 0. So again, it depends on preference. For each of you, it depends on preference. I have a model here using is positive. If I were to build this model for myself, I would have probably used larger a than b, but I just want to show that it is possible to use this positive, and I want to integrate an interactive register in another model so you can see what happens. What we have here is a type of a racing game. We have car 1 and car 2. They both generate d50 distance, which is between 1 and 50 distance each step. So you're not going to see resources moving through here because all of the connections are instantaneous. So when I hit play, you're going to see resources coming in and out. Now, what we have here is a sort of a mechanic for catching up to the one that is ahead. So I'm checking is positive a minus b, is essentially making a comparison between the two distances. And the one that is behind, you're going to see that the respective car's arrow on exiting the gate becomes active, and that car receives an extra 10 flat distance per step. So it's gaining up on the opponent that is ahead. Now 10 is not a big mechanic. If you want to do it mid-execution, so for instance, let's change the step to 10 and turn it up to 50. If you do it 50, it's probably going to switch every 2 steps or every step. So you see that that type of catch-up mechanic is a bit exaggerated. If you want to decrease it to 10, you can see that maybe it's not enough. So again, it depends to preference, and having an interactive register can help you see just how influential your catch-up mechanic is. So this is a simple one. Again, we could have used different formulas here, not just relational, bunch of other formulas as well, just comparing the two. And with this model, I think my job here is done, but Matthew's job is just coming up. So if you have any other questions, please let me know, but I'm going to stop sharing now. I'm going to leave the stage to Matthew because he's got an awesome diagram to show you.
Fantastic. Thank you very much, Cesar. And I'm sure you'll help me answer questions as we go into this next section. So here's a quick model we just put together just to kind of show you, now that you hopefully understand all the different types of uses of registers, wanted to show you some of these registers in action. So this is a quick model we put together. My little red counter here is my player, and we've created, just as we did in the Hades webinar, this option where we've got different types of activities that the player can go into. So here, the first thing is a player's going to go and find ingredients. They're going to collect those ingredients there. So every time they come into this pool, they're triggering this source, which is providing ingredients. Once they've found some ingredients, they're going to craft them into items. And once they've got enough items to complete their mission, the complete mission option will also be available. So just to quickly kind of talk you through how I'm using registers here. So the first thing is, you'll notice they found some ingredients. They come into my pool here. I'll pause it there for a moment. I then have an array. So the number of ingredients required to craft an item actually increases every time. I could have used a number of different ways of kind of creating this logic. What I've done is I've created an array that's going into this register as the letter A, and then I'm using this to send the message out to different points. So firstly, it's going into this resource connection to say, this is how many resources are required. I'm also sending that as the letter B into this third register, and this register is receiving the letter A from the ingredients, and it's going to say if A is equal or larger than B plus 1, or 1 plus B. And the reason I haven't just done that equal or larger than B is I have 1 on this resource connection as standard, and then I'm influencing it with this register. So I only want this crafting option to be available when there's enough resources in there to craft. So you'll notice right now there are 8 resources in this pool. If I play a step, you'll see the only option for the player is to go and find ingredients. That's going to trigger my source. I now have enough ingredients. So the number 9 is being sent to the resource connection. The number 9 is being sent to this formula, and it's saying, yes, there are enough. Therefore, it's returning the number 1. I've got a greater than 0 coming over to this resource connection, making this an available option. Then on these connections, I'm using different percentages to say, what's the player most likely to do? Now, I've made this one 100%, so I don't want to lose any resources, and it's always available. I've made this one 400% because I've said, well, the second the player has enough of those ingredients, they're going to go and craft them, but maybe not every time. So now if I click this, we'll see where the player decides to go. They're going to go and craft their items. This is sending a trigger to my converter. So in the next step, it'll pull those resources through and create them into items. Now, up here in the top left, I've got another register, and here I've got quite a big formula, and I'll zoom in on this so you can have a good look at it. And what I've done is I've created a number of different levels. So I've kind of broken this down into a number of missions, and I've said, right, during the first mission, so when the mission, which is this connection, rather than using a letter, I'm using a word, and I'm calling that mission. When the mission equals 1, multiplied by larger items than 0. So the first mission, you have to have 1 item. So by multiplying those two together, it's making it a AND type logic. And I'm taking that and multiplying that by 1, so that it's going to output the number 1 when that's satisfied. For this second mission, so when it's on mission number 2, as it is now, I've got mission equals 2, great, and items larger than 2. So over here, my player's now crafted 3 items, and I'm taking that and I'm going to multiply that whole thing by 3. So you'll see my register is outputting the number 3. Using that, follow this logic line along, it's over to this resource connection. So it's going to drain these 3 items into a drain once the player goes into complete mission. So hopefully now my player is going to choose to go into complete mission. You'll see these connections have gone blue. One more step. It's going to drain down my items. I'm going to trigger a source that's going to increase my mission number. So my register is now saying, well, equals mission to 2. No. So anything multiplied by 0 is 0. And it's now saying equals mission to 3. And it's going to wait until my items are larger than 4. When it does that, it's going to say, right, multiply that whole thing by 5. So if I let this play, because this has been reset, it's back down to 1. So it's going to gradually increase the number of ingredients for every time it's crafted. And we're going to gradually build up that logic. And this is just a really quick example that we put together just to show how you can use registers in a number of different ways. I think creating these types of formulas where you're actually combining multiple different inputs and even kind of creating a different stage where you're having different outputs and different requirements available at different times to control your logic is a great example. So, love to know if you have any questions. Does this make sense? Please do drop your questions into the chat or into the Q&A. So now my player is going to get to, they need 14. One of the reasons of using this I found really useful is you can use a power formula, as we showed you before, for that type of upgrade progression type system. This way, rather than kind of having a formulaic method to it, I wanted just to show how you could use this to really set those individual numbers each time. Perfect. So I think we did have a question. Can I create a register array from a pool? For example, I have a pool with 10 resources in. Can I add a connection from the pool to the register to create an array that has 10 elements that go from 1 to 10? Cesar, help me out with this. I think I understand it. So you kind of want to have a pool that's going to have something in 10 resources, add a connection from the pool to a register which has 10 elements, go from 1 to 10. So I guess let me stop this for a second.
I understand the question, and the answer, can you do it, is yes, but not in the way that you think. I mean, it's not going to be efficient. You can send 10 as a variable, but then you have to write your array manually. So like the first element is going to be a minus 9, then a minus 8, a minus 7, and so on. So you'd better just do it 1, 2, 3, 4, 5 actually than doing it this way. So can you do it? Yes. Should you do it? Probably not. It's not worth it.
Perfect. Great. Well, what's going to happen next? In a moment, I'm going to turn off the recording. When you leave this session, what will happen is it will take you through to our survey. Once you've completed the survey, just to give us any feedback or any other input about today's content, it's then going to take you directly to the Machinations 102 model, where you'll be able to see everything that Cesar's built and be able to play about with that and see how we've constructed and how all those Maths.JS functions operate. Love for you to hang around. Once I've turned off the recording, if you want to, just raise your hand and you can come up and have a chat with us. In the meantime, if you have any questions about the licenses or what type of options there are in order to kind of build your Machinations models, always here to come and have a chat with you. I'm available at matthew@machinations.io. Perfect. And I'm going to stop recording.